Hello everyone. Today we are going to discuss the most easiest scoring and interesting topic, which is arithmetic progression. Children, this topic has a weightage of 4 marks in your board examination, bifurcated in 1 marker and 3 marker question. Children, this chapter is all about 2 formulae, but before telling you these 2 formulae, I would like to introduce you the meaning of arithmetic progression. Let's understand its meaning by taking few examples. Say, I have a list of number as 1, 2, 3, 4 and so on. And in example 2, say I am taking it as -3, -2, -1 and so on. Children, these are 2 different examples, and by observing these 2, you can say that if I add 1 to this, I mean first term, then I can get my next term. If again I add 1 to this, I can get my third term. If again I add 1 to this, I will be getting my next term. Here also, this is -3. If I add 1 to this term, I will be getting the next term. If I add 1 to this term, I will be getting the next term. That means I am adding a fixed number or a term in the preceding term to get my successive term. This is, the next number is known as successive term, and this is your preceding term. That means your numbers which are consecutive, they are differ by a fixed number. They differ by each other by a fixed number, and this fixed number is known as common difference. Which is denoted by small d. That means these 2 numbers, these 2 consecutive terms differ each other by a fixed number. That's why it is called as common difference. Now children, I am saying you are adding some fixed number in the preceding term to get the successive term. It doesn't mean that your fixed number should always be positive. It can be, the fixed number can be negative as well. For example, if this is your list of number, then you can see here, if I add -1 to it, then I will get my next term. If I add -1 to this, then I will be getting my next term. So here I can say that common difference can be negative, positive, and it can be 0 also. So your fixed number, which is a common difference, can be positive, can be negative, and can be 0 also. So now I can define my arithmetic progression as a list of number which is obtained by adding a fixed term in the preceding term to get the successive term. So this is your arithmetic progression's definition. Children, you can have arithmetic progression as finite progression, and you can have it as infinite list of numbers also. That means it can end up to some number, say nth number, which is written in variable form, and it can move to infinity also. In class 10th, we are going to read about finite terms. So let's see how I can form the formula. Let's say this term is A1, this term is denoted by A2, this term is A3, and say this is my nth term which exists somewhere. So this A1 is your first term, which will be always written as it is, because I have not done anything with this first term. So your first term will be not added up with any fixed number. This first number will be a fixed number. Now to get the next number, say D is your fixed number. If I am taking D as my fixed number, then this term can be calculated by adding this D in your preceding term. So your A2 is now A1 plus D. If I want to calculate the next term, then I will be adding D, which is a fixed number, to this preceding term, that means this is your preceding term a1 plus d, and if I'll add 1d to it, then I'll be getting a3. So I'll be doing it like this till nth term. So here what I can write here, before this term the preceding term will be a1, or I can say this is nth term, so preceding term will be an minus 1th term. Children, here on solving it I can say this is my a1, this is my a1 plus d, this is my a1 plus 2d. So here my nth term can be written as a1, that means I am getting a1 everywhere. So a1 plus, you see when I am calculating third term I am writing 2 here. When I am calculating my second term I am writing 1 over here. That means when I will be calculating nth term I will be taking 1 less than n, and then I am writing d over here, so I will be writing d. So this gives me the formula to find out the nth term. So this is the formula which you have to remember. A nth term, that means nth term can be calculated by using a plus n minus 1 into d. So this is your first formula which you have to remember. Now let's see, if I want to find out 12th term, then I can write it as a plus 1 less than 12 is 11d. That means a is the first term, d is the common difference, and this is your 12th term. Here I can define, this is your nth term, this is your first term, this is the number of terms in the given list of numbers, and this d is the common difference. So this is the formula which you have to apply to find out some term. Say if I want to find out 100th term, then I will be using it as a plus this n, this is your n. So n minus 1, that means 100 minus 1, which will give me 99d. So if I put the value of a here and d here, then I will be getting my 100th term. So children, to find nth term of an AP, arithmetic progression, in short can be written as AP. So if you want to find out nth term of an AP, then you can always apply this formula, which is nth term equal to a plus n minus 1 into d, where this is your nth term, this is your first term, this is your number of terms, d is your common difference. Alright, now we'll talk about sum of the arithmetic progression. Children, if I have a1, a2, a3 up till anth term, and if I want to find out sum of all the terms, then it will be a very hectic task to add all these numbers if it contains bigger numbers, bigger values. So to simplify the problem, mathematicians has given us a very simple formula, and that is sum of nth term can be written as Sn n by 2 2a plus n minus 1 into d. So this is the formula to find out sum of n terms. This n is number of term, this a is again first term, this n is number of term, this d is common difference. Let's see how we can derive this formula. Children, look, this a1 can be written as a1, this a2 can be written as a1 plus d, as I have told you that this term, successive term, can be calculated by adding a fixed number to your preceding term. So I am adding this a1 plus d. Let this be a only, so that it can come out to be in this form. So this is say a. Now next term can be calculated by adding a fixed number. Again this third term can be calculated by adding d to this. So a plus d will be a plus 2d plus so on, and this anth term will be a plus n minus 1 into d. So this is my one equation. Say this is your sum of the series. This is your actual list of numbers, and this is your arithmetic progression, and I want to find out sum of this series. So say we denote it by capital S. Now if I reverse this equation, then I can write it as, this will be same. I am just reversing them. I am writing this here, a plus n minus 1 into d, so on. Again this plus a plus 2d plus a plus d plus a. So this is my equation 2. If I add these two equations, then what will I get? Adding 1 and 2. So if I add this term and this term, so I'll be getting here, first of all let's add your left hand side. So s plus s will give you 2s, this will give you 2a plus n minus 1 into d, and then you will be adding the next term also to it. So you will be getting it like this. So here it will be, say what will be the next term over here? That means I am moving in descending order. Here it is a plus n minus 1d, and then I am moving to the first term. So I am moving in descending order. So if I want to write the next term, I can write it as a plus n minus 2 into d. So add this and this, you will again be getting it as a plus a will give you 2a plus n minus 2d, n minus 2 into d plus d will give you nd minus 2d plus d, which gives you nd minus, this will be minus d, and d can be taken out, so again n minus 1 into d. So 2a plus n minus 1 into d, and so on. So you will be getting, at last what you will be getting, if you add this and this, then again you will be getting it as 2a plus n minus 1 into d. That means 2a plus n minus 1 into d, 2a plus n minus 1 into d, 2a plus n minus 1 into d. These are your nth term. That means if you are adding, say 1 plus 1 plus 1 plus 1 up till nth term, if you are adding it, then you will be getting it as 1 into n. So simply here I can get it as 2a plus n minus 1 into d into n. This complete is multiplied with n. Okay. So if you add any number n times, then you will be multiplying the number with your n. So this is your 1 number, this is again next. So I am adding 2a plus n minus 1d. That means the same number is added n times. So it will be n into this. So here it is 2s equal to this. So I can write s equal to n by 2, 2a plus n minus 1 into d. And which is your formula to find out sum of the given AP. So this is again an important formula which you have to remember. So children, we have just two formulae. One is to find out nth term of an AP, and another is to find out sum of nth terms. So these are two formulae. Children, we have one more formula to find out sum of n terms, but this is a special case, and it should be used only when the first number and the last number is known to you. And the formula for this is n by 2 a plus l. In place of l, you can write an also. This is your last number, and your last number in the series is an. So either you can write a plus l, or you can write a plus an. This formula is used only in special cases when the first and the last number is known to you. So these are the three formulae which you have to remember for this chapter, and that's all for this chapter. In the next video, we are going to learn how we can apply these formulae to find out the nth term and the sum of the AP, which is arithmetic progression.